From this week, we are going to move on to a new chapter, Chapter 8, another special type of mathematical expression that is called radical expressions. When we see the word radical here, okay, that's radical expressions. Okay, we'll still do the same thing as we did on the rational. So we get to know what a radical expression is. How do we simplify it? How do we add, subtract, multiply, divide the radical expressions? And then the last thing, we are going to solve a radical equation. It's a very similar format of chapter 7 when we move on to chapter 8. So when we're looking at the radical expression here, we have to know that special symbol. So let's see, this one, that symbol. It is called a radical symbol or radical sign or square root symbol or square root. Okay, so that symbol represents what? It represents the opposite operation of raising a perfect square. Okay, so this I write a very small 2 here. This is a power of 2 or exponent of 2. So take the square root and raising a perfect square. Those two are opposite operations. And let me see. So if we have a number b here, so when we see this, so how are they related? So if I have this one, the perfect square of b, or b squared, equals another number a. So this is where we see the power. Square of a number b equals number a. And then we can see b, the base, is equal to square root of a. Or we see radical a. There are different kind of saying. They all mean the same thing here. So this is how they're related. And this is the radical symbol. What do we, so in any expression which has a radical symbol, they're called radical expressions. And for any radical sign, the expression within it, so we have a, here's anything inside of or underneath or enclosed by the radical symbol. So that one here, they have a name, they are called radicand. Okay, they're called radicand. Anything inside the radical symbol, they're called radicand. Okay, this is one terminology. And those two mathematical expressions tells us the relation between the perfect square and the square root. So b is equal to square root of a or radical a. Okay, they mean the same thing. So this is how they're related. And from the expression here, we can also treat this as one definition. So this is the definition of the radical expression here. For any radical expression, we'll see, so when a equals a square of another number, so this number a can never be a negative. We're talking about a real number. Okay, we are not talking about the imaginary number or complex number that is beyond our algebra level here. So when we are talking about for all real numbers, b and a are both real numbers. If a equals square of b, so then a can never be a negative number. It can be 0 when b is 0. And if b is not 0, then square of a non-zero number is always a positive number. Okay, so then when we write this, the second expression, when a turns into the radicand here, we know. So this is one thing we have to bear in our mind. For any radicand, the radicand will always be greater than or equal to 0. It can never be a negative number. So no radicand is less than 0. Remember this rule. No radicand is less than 0. Okay, they're all greater than or equal to 0. So keeping this in our mind, we'll be using that in the future. Okay, so this is the radical symbol, the radical sign means, and let's see. How do we, so we know what the radical expression is. So the next thing we are going to do will be given one radical expression. We want to simplify it. How do we simplify a radical expression? Before we start, I want to give you a quick review about some special perfect square numbers. When we are working on the problems in chapter 8, we should be able to recognize those special numbers. What special numbers? Those special numbers, they're called perfect square numbers. Okay, so I want you to see number 1. 1 equals 1 squared. And another spark number is 4. 4 equals 2 squared. Then also 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81, and 10 squared equals 100. So when we see those numbers, number 36, I want you to recognize 36 equals 6 squares. 36 is a perfect square number. It equals 6 squared. And those numbers just, okay, the base number are less than or equal to 10. And I also want to continue here. When you see this number, 121, you should recognize this 121 equals 11 squared. And when you see the number 144, you remember 44 equals 12 squared. And if you see the number 169, that equals 13 squared. When you see 196, I hope you know it equals 14 squared. When you see 225, you know it equals 15 squared. 256 equals 16 squared. 289 equals 17 squared. And 324 equals 18 squared. 361 equals 19 squared. And 400 equals 20 squared. Okay, and those are not mandatory, but it's very helpful if we are able to recognize those numbers are getting much bigger. Okay, and they're not very commonly seen and those smaller numbers, but I hope I give you some impression today. When you see those numbers, you notice they are some special numbers. They're called perfect square numbers. Okay, so having all those in our mind here, now I'm going to, give you one problem. Please simplify square root of 49. Okay, as you say, so if you recognize 49 equals 7 squared, right? So we can write this down, and gradually we really don't have to write. Put this on paper. We have this in our mind. 49 equals what? Equals 7 squared. Okay, square root of a square. I have told you, square root and the power of square, they are opposite operations. And that means those two cancel each other. I will have only 7 left. Or in another word, having this one here, when we have a square of a number and the radical symbol, we can move the base out of the radical symbol. So 7, because 7 has a square within the radical symbol here, so 7 can be moved out. And its exponent turns into 1. We don't have to keep the 1 here. Or you can remember my words here, the square and radical symbol, those two are opposite, so they can cancel each other. Those two operations, they cancel out. We have only 7 left. But I prefer you remember so any number within the radical symbol. If it has a power 2, it can be moved out of the symbol, moved out of the radical symbol here. Okay, so this is the one here. If I have this expression within the radicand, I not only have a number 49, I have another letter with it, 49 times a. So 49a, radical symbol, the square root of 49 times a. How can we simplify it? We have noticed, we have done this, 49, that's 7 squared. We write 49 as 7 squared. What is a? A is a. We can do nothing with it, so a is still a. Okay, so when we simplify a radical expression, it means we want to move as much as possible out of the radical symbol. That is called to simplify a radical expression. To simplify, we want to move anything that is possible out of the radical symbol here. Make it out of that square root symbol. So what can we move out? 7, because 7 has a square within it. So 7 can be moved out. When we move out, this 7 out, this 2 is gone, because 2 and this radical symbol, they cancel each other. So 7 now is out. How do we deal with a? Can we move a out? No, because this a does not have a square term. It does not have a power. It has to stay within the radical symbol. A stays here. And this is the final answer. We said we have simplified this radical expression because we have moved whatever we can out of the radical symbol. 7 is moved out. So when we moved 7 out, make sure we never keep the square anymore. 7 squared. Radical of 7 squared, that's 7. And a stays in. Okay, so remove to simplify a radical expression. It means we move as much as possible out of the symbol here. Okay, so now if I give you another one. So you might ask me, Professor, if we have this expression, 49 plus 8. Okay, I know what is 49? 49 equals 7 squared. This is plus. Okay, add a here. For this case, can I move the 7 out of the symbol? The answer is no. Okay, and when we simplify a radical expression, we should move the factor out as much as possible. So this 7, 49, that's a factor. It is multiplying a. It is, okay, multiplying a here. 49 is a factor. We can move the factor out. But for this one, this 7 squared of 49 is not a factor. It is when added, they're added together. For that case, we cannot move the 7 out. So this expression here will stay as 49 plus a square root of 8. Nothing can, why? Because can we simplify this one? No, if we cannot simplify, the entire thing will be one factor. So try C again. We use what we have learned in chapter 6. I said chapter 6 is the foundation. Now you'll see when we are working on a radical expression, we want to move as much as possible. Move what out? The factor out as much as possible. For this one, 49 plus a, the entire thing is one factor. And this factor does not have a power 2. It has power 1. So it will stay within the radical symbol. So that will be still 49 plus 8. So I want you compare those two problems. A very common mistake. We notice, oh, I'm very glad I know the number 49 is equal 7 squared. Perfect. So I will move 40 out of symbol as 7. No, because this 49 is not a factor. We can only move the factors out of the symbol. Means it's part of the multiplication. All right, so this is the introduction part here. Now let's do one practice. So I have a practice sheet right here. Please find the value of the radical expression, or in other words, simplify it. So I hope when you see this, it means 5 times square root of 196. What does this equal to? So 5 is 5. Multiply times what is radical 196. I hope that you remembered. 196 equals 14 squared. So the square root of 196, that equals 14. You do not have to use your calculator, all right? And 5 times 14 equals 70. And this is one simplification problem. Okay, and then let's practice a few more right here. If I have this one, what does this equal to? So simplify or evaluate this radical expression. It equals negative 3 is negative 3 times radical 64 equals 8, because 64 equals 8 squared. And then that's negative 24. So this is the first type of the problem. And then if we see one here, simplify this one. Square root of 125 equals what? Equals 15. Why? Because 125 equals 15. And okay, so here the problem will be getting a little bit harder here. I have this one, negative square root of 99. So this negative sign stays. When we see the number 99, you'll tell Professor, 99 is not a perfect square number. So I cannot do anything with it because 99 does not equal to any number squared. And okay, so don't treat this. When we have a number inside of the radical symbol, let's try to, if the number itself is not a perfect square number, let's factor it first. Use the factor tree. What is 99? 99 equals 9 times 11. That's 99. So now I break 99 into a product. So 9 is a factor. 11 is an also factor. When we see the number 9, you notice 9 is a perfect square number because 9 equals 3 squared. Or you can rewrite this negative 3 squared times 11. 3 squared now can be moved out because of the square term. We move this one out, I will have 3 only. So 3, and how about 11? This 11 will have to stay inside because it does not have a power 2. It has to stay inside. Final answer. This is a simplified expression of this one. Okay, and I want to show you a few more examples. What if we have some variables? Okay, so before we start here, let me go back here. So what if I have shown you a numbers? What if we have one variable or multiple variables? So if I have a to the 4th. Okay, so for any exponent, when it is an even number, and so recall, when we have the exponential notation rule, raise a power to power. Okay, so a to the m is a power, and then raise power to n. So what do? So we are going to keep the base, multiply the two exponents. This is from Algebra 1. All right, so when we have a rational, when we have one variable, if its exponent is one even number, then it can always be treated as something squared. So a raised the power to what? We'll get a to the 4th. A squared, see, a square squared. We keep a, 2 times 2 equals 4. Therefore, a to the 4th can be seen as a squared, then squared. Take the square root now. Now we know this radicand turns into something squared. So this square and this radical symbol, those will cancel out. I can move the base out of the radical symbol. What this equal to? It equals a squared. So radical a to the fourth equals with a to the second power. Similarly, I want you to remember if I have a to the sixth, what does this equal to? It equals a to the third. So mainly you just divide the exponent by 2. Then that is the left here. So a to the sixth square root equals a to the third. If I have a to the 10th equals what? Square root of a to the 10th, a to the 5th. So I want, from now you know if one variable, one factor, okay, it has to be a factor, has a even exponent, it can be moved out of the symbol completely. There is nothing left within the symbol, and this exponent will be half of the old exponent. So this is how we deal with the even exponent. If we have an odd number, you must ask me, Professor, what if I have a to the 5th? 5 is not an even number. That means we cannot do anything with it. The answer is no. We still can do something. Why? Because a to the 5th can always be written as a to the 4th times a. So we just write one base out, so a, and then times what? Times 5 minus 1. So remember, recall, when we have a same base exponent notation, when they are multiplying, we'll keep the base, we add abstract. So a to the 4th times a. A means a to the 1th equals what? Equals a 4 plus 1, a to the 5th. Okay, this is called the product rule. Keep the base, add the exponents. So all odd number of exponents, we can always treat this as an even number. This even number is an even number, just 1 less than 8. Multiply the base. So a to the 5th equals a to the 4th times a. Then we'll see how much can we move out. First, we determine this multiplication. This is a factor. So the factor means it can be moved out of the symbol if possible. So a to the 4th can be moved out. We have done this before. That means we have a squared outside. And how about this a? Okay, I'm sorry, you have to stay inside. A squared times a, final answer. Similarly, okay, if you have a to the 7th, you'll write this as a to the 6th times a. So a to the 6th can be moved out as a to the 3rd times radical a. This is how do we deal with a single variable when they have the exponent other than 1. So great, if that is 1, they'll stay inside. Other than 1, 2, 3, 4, 5, and so on. We'll say even number, move out completely. Odd number, leave 1 inside, and then move the remaining part. If we have multiple, so I just show you just one variable. If I have multiple variables within the exponent, I have a to the 3rd times b to the 8th times c to the 7th. Okay, so if I have one radical expression like this, how do we simplify with that? Same thing as we just did before. Treat or deal is with every variable because all those, they are factors. So a to the 3rd means a squared times a. B to the 8th means b to the 4th squared. And c to the 7th means c to the 6th times c here. Okay, so I really don't have to write this. You can just keep this b to the 8th. Then let's see what can be moved out. This one can be moved out. This one can be moved out. This one can be moved out. All even exponent can be moved out. When we move them out, the exponent should divide by 2. So a, 2 divided by 2, that's 1. Okay, b, that should be 8. 8 divided by 2, that's 4. B to the 4th. C, 6 divided by 2, 3. So we write down whatever can be moved out and then keep the radical symbol. What is left? We have 1a left, b is gone completely, and we still have another c, so radical ac. That will be the final answer. If we have a number, okay, in front of it, for example, if I have 18a to the third, how do we deal with that? You see, 18 is not the perfect even number, but we can use a factor tree. 18 factor tree equals 2 times 9. What is 9? 9 equals 3 times 3. So that's 18. So 18 equals 2 times 3 times 3 means 3 squared. That's 18 times a to the third. A to the third means a squared times a. So this is 18. I factor 18 complete using the factor tree. And a to the third, this is an odd number. I rewrite it as an even number exponent times another a. And then let's see, what can we move out? We can move this out and this out. And 3 squared, move out, that's 3. A squared, that's a. What is left? 2 and a. Final answer. That's it. So don't be scared when we are trying to simplify a radical expression. We just need to move the factor out as much as possible. Sometimes, special case like here, we'll see a like a quotient within the radicand. It's not, so this is not, they're not multiplying, they're dividing. That's the same thing here. All right, so 16, we know 16 can be moved out. It equals 4 squared. When we move this out, 16 belongs to the numerator, so 4 is still on top, on the numerator. This 9 was on the bottom. When we move 9 out, it will still be on the bottom. 9 square root of 9 equals 3. So that equals 4 over 3. Okay, and let's see this one here. Let's see this one. This negative sign always stays. X squared, can we, no, x to the fourth, can we move x to the fourth out? The answer is yes, it will turn into x squared. Okay, it is on the top, it's still on the top. We draw the bar here. Then look at the bottom, 49, we can move this out, it turns into 7. And y squared, we move this out of symbol, it turns into y. Okay, that is the final answer. So we can move the factor or numerator denominator. Those denominator can also be treated as a factor. So just in case you see a problem like this, don't be scared. Do the same thing as we move the factor, the multiplication out. It's the same thing for the division. All right, so this is the first part of section 8.2. And I want to, okay, give you one more type problem. Let me go back to the beginning here. Okay, so we know if I have a equals b squared, therefore b equals radical a. And if I raise a square to a radical expression here, when we see radical a and then raise a square, what does this equal to? It's the same thing as we did before. Square and this radical symbol, they cancel each other. It equals the radicand a. Okay, it's the same thing right here. So b equals radical a. We can take the square on both sides. B squared equals a. So remember another thing. Whenever we raise a square to a radical, whatever that is, I use capital A. Okay, rewrite it. Radical A and the square of a per radicand equals, no, square of a radical expression equals the radicand itself. This square and this radical symbol, they cancel each other. We'll leave the A here. This capital A can be any number, can be any expression. So this, you might see some problem on the homework as well. And this basically what we get on section 8.1, Introduction to Radical Expression, and how do we simplify a radical expression. Take your time to deal with numbers and then to deal with variable by variable. Okay, let me stop recording for this part.